Hello, let's take a look at an overview of the Pier footing calculator in ClearCalcs. We are designing in US standards as per IBC 2018, and the assumptions are stated here. In the properties, you can define the pier diameter. If you are designing a square footing, you can also enter the diagonal dimension. The embedment depth is what will be considered in lateral loads, and the height of the pier above ground is what sticks out above the soil. The lateral constraint at ground surface is for scenarios like a rigid floor or a pavement that would constrain the post above the surface. In concrete properties, you can define the strength and weight classification for your concrete. This is for the pier only and is unreinforced concrete. For the post and connection type, you can design either an embedded rectangular post, round post, or a post with a bracket and bearing plate. This is used to determine the concrete bearing calculations and will be based on either the concrete area from here or the bracket area. This calculator only analyzes the pier, so it should be noted that the post is to be designed properly and separately. Below are the property inputs for soil. Each are defaulted values based on the IBC. For the allowable lateral pressure per unit depth, it only considers the main ASD load combinations and not the alternative combos. So for example, we do not consider a 1/3 increase in allowable stresses from wind loads. Our last input is applied loads. The height above ground of lateral load application is applied to all of the lateral loads in the below table. It can be used for things like a deck where the lateral load is applied above ground surface. Within the table, you can define your lateral shear, vertical, or moment loads. This has tables in both of the X and Y directions. We also have the option to use a 50% reduction factor for live loads, as per the IBC. This is only applied in the LRFD combinations. We outline all of the ASD load combos and the governing axial load, as well as the LRFD load combos and the maximum loads here. The pier capacity calculations live all the way down here. The moment calculations both assume no axial forces and are both in accordance with ACI 318.14. Lastly, in pier embedment, we solve for the minimum embedment depth and the lateral soil stress at the designated depth. Both of these are calculated based on one of two equations, whether or not your soil is constrained. So if we go back up to the summary, all of these are used to compute the checks to see what governs our design, whether that be lateral soil stress, bearing pressure, the interaction between compression and bending, or shear strength.